Okay, so today we are starting a new chapter that is called as electrochemistry. Electrochemistry, again, I can say from the entrance point of view, is a very important chapter. The chapter is a full of concept, so that's why the chapter becomes a very important. Electrochemistry, as the name says, somewhere here I'm talking about the electrical energy and the chemistry. It's a combination of electricity and the chemistry. So here this is the branch of chemistry, I can say, that which deals with the interrelationship between the electrical energy and the chemical energy. Here there are the certain processes. Here we are going to learn about those processes in which the electrical energy is converted into a chemical energy and chemical energy is converted into electrical energy. So we have here we are going to learn about the conversions like electrical to chemical energy, or I can say chemical energy to electrical energy. Electrical energy to chemical energy, which type of conversion it is. Here see, I know that in case of electrical energy to chemical energy, there are the certain reactions which do not occurs by its own, So such reactions are carried out by using electricity. That means by using electricity, I'm carrying out that reaction. Example, I can say the electrolysis of NaCl, obtaining a sodium metal from a NaCl by electrolysis. So when electricity is applied, then chemical reaction takes place or chemical reaction occurs, I can say. The second, I can say, chemical energy is converted into electrical energy. Here some reactions are going on, and due to that reaction some heat energy is generated, and that heat energy is converted into electrical energy. And that's why this conversion is called chemical energy to electrical energy. The example for this, I can say, the battery which we are using, all the types of battery. For example, I can say the battery which we are using in our mobile. Simply, for the functioning of a mobile, we require electricity, and here we are using continuously everywhere the mobile. That means it's not like if I'm using a mobile only when it is connected to the socket or it is connected to the electricity. We use it anywhere. How? Because it means for functioning of the mobile we require electricity, and from where we get that electricity, then simply we say that a word that is from battery. Now what battery is, that battery contains some chemicals inside, and those chemicals react with each other, and during that reaction certain electricity is generated, and the same electricity is used for the functioning of the mobile. That mobile, or I can say the mobile which we are getting using in a torch, or the battery which we use in a watch, or the battery which we use it in while using an inverter, all these batteries are containing some chemicals, and those chemicals react together and they produce a certain electricity, and the same electricity is used to carry out this process for the functioning, that is of that particular electrical device. So here we are going to learn about both the things. In this part here, I'm just considering the chapter into three parts, dividing the first part. In the first part we are going to learn about this conversion, that is electrical energy into chemical energy, while in second part we are going to learn about the conversion of chemical energy into electrical energy, and third part is slightly different from these two, about which we will learn, about which I will tell you all the things when we are going to learn the third part. So let's start with the first part and second part. Let's see what is the difference between these two parts. Okay, now let's see the differences. The differences, the first one with respect to the process. So here, as I said, in case for the process, in the first part, here we are converting electrical energy into chemical energy, while in this case the chemical energy is converted into electrical energy. To carry out this process, we use certain device, and that device is called as a cell. In a simple word, this device is called as a cell, which contains some electrode and some electrolytes. So those device the device which we use for the conversion, such conversion of energy, is again divided into two parts, depending on which type of conversion is carried out, whether electrical is converted into chemical or chemical is converted into electrical. So let's see the name of a device, or I can say cell. So first part, that is a device. Here the device or the cell in which electrical energy is converted into a chemical energy is called as electrolytic cell. In second part, where the chemical energy is converted into electricity is called as electrogenesis. Electrogenesis, or also known as galvanic cell, or also known as voltaic cell, or we, in a simple word, we use the word battery. Then third, after the device, the third one, the reactions. When I'm talking about that, here we are learning about the relation between the chemistry and the electricity. That means there is some chemical reactions are going on. So in the case of this first part, the chemical reactions are, like I said, I'm doing the electrolysis of NaCl salt. So there is a inside Na plus and Cl minus. After the reaction, they produces NaCl. Sorry, sodium plus chlorine. Sodium gas and chlorine gas. Here the Na plus, I can say the oxidation number is +1, Cl minus is -1. When we get sodium, oxidation number 0, and the chlorine gas oxidation number is 0. We are going to learn about this reaction just after this difference. Now in this case, I can say that oxidation number of the sodium has decreases, that means it has gone under reduction. Chlorine has increased, that means it undergone oxidation. Means simply I can say that here the reduction which is taking place is redox reaction. So here we have redox reaction, but the reaction which takes place in case of electrolytic cell is always non-spontaneous reaction. Which type of reaction? Non-spontaneous. Well, in second part, the reaction which is taking place in this case, the example I can say zinc plus copper 2 plus iron, which gives zinc 2 plus copper. Again, about this also we are going to learn in the chapter. This reaction also, zinc. Oxidation number is 0, copper is +2, and its oxidation number is 0. That means again I can say that here also the oxidation number of zinc has decreased while the zinc has increased, and the copper oxidation number has decreased. Again there is a change in oxidation number, means I can say that the reaction is again a redox reaction. And this reaction is spontaneous redox reaction. What it is? Spontaneous redox reaction. Then let's talk about the anode and cathode. What is anode? Then I will simply say that anode are the device where the electricity is converted into a chemical energy. Anode is a one electrode where the oxidation takes place. Oxidation takes place. The definition is same in this case also, that is second part also, that is anode is a device where electrode where the oxidation takes place, while the cathode is a one where reduction takes place, and here also the definition is same. Then what is different? Anode, in case of electrolytic cell, the anode is positive and the cathode is, in case of electrolytic cell, the anode is a positive and the cathode is negative. While in case of this, anode is negative and the cathode is positive. I will tell you that the charges never represent whether the given electrode is anode or cathode, but I can say that positive and the reactions which is taking place on it decide whether the reaction is whether the given electrode is an anode or cathode. So it's totally decided by the reactions which are taking place on the electrode. After the difference, now let's start with the first part, that is electrolysis. Electrolysis, where I can say the electrical energy is converted into a chemical energy, and the device is called as an electrolytic cell. Okay, so this is called, the name of process, this is called electrolysis. And this is called electrogenesis. And when I say it's a device name, then it's not electrogenesis, it's electrogenetic cell. So electrolysis and electrogenesis. Electrolysis, that means electricity is consumed. Electrogenesis, that means electricity is generated. Okay, now let's start with the first part. That is electrolysis. Now in this electrolysis, what things are what things are required. Here the first thing, electrolysis I am doing, that means electrical, I am converting electrical energy into chemical energy, and for this the cell which I am going to use is going to be called as electrolytic cell. Here I am considering the example, that is the formation of the electrolysis of NaCl. Example, electrolysis of molten NaCl. Molten NaCl, that means liquid NaCl. NaCl can be converted into liquid by either by heating or by dissolving into the water. So here I am doing electrolysis of molten NaCl, that means we are just heating it. So what things are needed, then simply I will say here the required things are anode, cathode, that is the two electrodes, and there is a one that is a electrolyte is required, that is a molten NaCl. So now let's see what happens when the electrolysis is carried out. This is positive electrode connected to the positive terminal of the battery. This is negative electrode connected to the negative terminal of the battery. Here we have taken the molten NaCl, that means inside there is a Na plus and Cl minus ion. The large number of NaCl, molten, that means in a liquid state. So all that, due to that heating, all the NaCl has been separated. So ultimately we are having the large number of Na plus ion and Cl minus ion. So as I said, the required things are the two electrodes, one is positive and one is a negative. There are the ions like Na plus ion and Cl minus ions. Now let's see the reactions which are going on. Once I pass the electricity, the ions will start migrating toward the opposite charge electrodes. All the ions will start migrating toward the opposite charge electrodes. So what reaction will take place on anode and cathode? So sorry, on positive electrode and on negative electrode. Here, as I said, the positive, or we till the reaction, before starting the reaction, we have only electrodes like a positive and negative. After starting the reaction, I will come to know that what is anode here and which electrode is an anode and which electrode is a cathode. So before starting the reaction, suppose there is a at positive electrode, I can say, let's see what is happening. Positive electrode, where the negative ions will come, negative ions like Cl minus ion will get attracted on the positive electrode. Cl minus, since that negative charge represents that it is having an extra electron, so it will lose that extra electron and will get converted into chlorine, and one electron is lost. So I can say this is oxidation, loss of electron. And Cl, chlorine never exists in the form of Cl, it's always Cl2, chlorine molecule. So for Cl2 there should be 2 chlorine ion, and each chlorine will lose one electron. So since oxidation is taking place, so I can say that this positive electrode is acting as an anode in case of electrolysis. Okay, now let's see what reaction is taking place on negative electrode. At negative electrode, the sodium ion will come, because of the opposite charge. Sodium again have a plus charge, and being a plus charge, it will gain electron and will form sodium metal. So this is nothing but the reduction. This is nothing but the reduction, I can say. So Na plus N electron is giving sodium, but ultimately I will add both the reaction to get the overall reaction, because this is the reaction, and since the reduction is going on, so I can say that this is cathode. To get the overall reaction, I'm going to add both, and for the addition the number of electrons should get cancelled, so I'm just multiplying this by 2, and here the multiplication is done only for the cancellation of electron. So now let's add this and this reaction, so that I will get overall reaction. 2 moles of Na, sorry. Okay, so 2 electrons will get cancelled, and finally I will have 2 moles of Na plus and 2 moles of Cl minus, which will give you 2 moles of Na plus Cl2. So this is the example of molten NaCl, the electrolysis of the molten NaCl. Okay. Now let's see the another example, the same electrolysis, but now here it is the electrolysis of, that is example number 2, electrolysis of aqueous NaCl. Now aqueous NaCl means the water is also there. Positive and negative. That is again a positive electrode and negative electrode. Aqueous NaCl, that means ions will be Na plus, Cl minus, there is a 2 more ions of water, that is H plus and OH minus ion. So finally we have these ions inside. Now once I pass the electricity, again the ions will start migrating toward the opposite electrode, and when these ions will start migrating toward the opposite electrode, then what will happen? Sodium will move to this, sodium, and okay, so let's see what will happen at positive electrode, or sorry, the negative electrode or positive. So negative electrode, first I'm starting at negative electrode. At negative electrode, 2 ions will approach, that is a sodium ion and H plus ion, and both will try to gain electron from this negative electrode. Suppose if the sodium is gaining electron, then it will form Na, and if H plus gains electron, then will form H, but H again hydrogen exists in the form of H2 gas, so 2H plus plus 2 electron. Now who will gain electron? It totally depends upon, both the reactions are the example of reduction, and since it is a reduction, that's why here again I will say that negative electrode is a cathode. Now which reaction will take place? Again it depends on the reduction potential. Reduction potential, that is which tells us the tendency of a substance to reduced. It is represented by SRP, that is called standard reduction potential. The reduction potential measure the tendency of an atom to reduced. Higher the SRP value of a given ion, more will be the tendency of the ion to reduced. So when we compare the sodium and Na plus and H plus ion reduction potential, that is SRP value, then I come to know that the SRP of H plus ion is more than Na plus ion. How I come to know? We will see that SRP and SOP series, and that from electrochemical series, that is which is also known as SRP series. We will come from that series, I will come to know that H plus is having a more tendency to reduce, and we will do that series just after this part. So here I can say that H plus and gains the electron and produces H2. As I said, hydrogen have a more tendency to reduce. So both will reaches to cathode, but only one ion will reduce, either Na plus and H plus. And since H plus is having more tendency, so H plus will reduce and Na plus will remain inside the solution. Okay, now after the negative electrode, now let's see what happens at positive electrode. At positive electrode, the ions which are approaching is Cl minus and OH minus ion. If Cl minus ion reaches, having the extra electron, negative sign represent. So Cl minus will give you Cl plus electron, but as I said, Cl never exists in Cl form, so 2 Cl minus 2 electrons. And if OH minus ion is reaching, then OH minus ion will give you OH plus electron, but OH does not exist in this form. So 4 molecules of OH will give you O2 and water. And 4 OH, that means this. Means ultimately I can say this reaction, I can say 4 OH minus ion is giving O2 plus water. So if OH minus ion is approaching, then it will produce O2 after the oxidation. Now who will oxidize first? So who will oxidize first? Here the oxidation is there, so it is decided by the SOP value. the iron having a higher SOP value will have more tendency to oxidize. Now, when we compare the SOP value of chlorine and OH minus ion, then I come to know that the SOP value of chlorine OH minus ion is more compared to chlorine. And since SOP value of OH minus ion is more, so ultimately which substance should form at the cathode? Then I will at positive electrode where the oxidation is going on, that is anode. So which substance should form at anode? Then I will say oxygen. But surprisingly, I come to know that at anode, instead of getting a oxygen, we are getting chlorine. That means I said SOP value of oxygen is OH minus is higher. So SOP, since SOP is more, so OH minus ion should oxidize. But instead of OH minus ion, which substance is oxidizing? The answer is chlorine. The question arises that why chlorine is getting oxidized. Then the answer given behind it is that the term is used called as over voltage. Over voltage, that means OH minus ion, the electron which is coming out from the OH minus ion have a very less kinetic energy. So to increase its speed, it requires some extra energy. And since it requires some extra energy, and due to which the SOP value of this becomes lower than the SOP value of chlorine. So because of over voltage, that is that requirement of extra potential, I can say the SOP value of chlorine becomes low, and since it requires more value, so SOP becomes high. So ultimately, instead of getting a OH minus ion, we get chlorine. Okay, so from here I will get from anode, cathode we are getting H plus, and from anode we are getting chlorine. Now let us add both the reactions. So chlorine electron will get cancelled, and what we will get as a net reaction, then I can say that net reaction will have H plus ion 2H plus 2 Cl minus ion is giving H2 from here and Cl2 from here. Means I can say during the electrolysis, Na plus and OH minus ion will remain in the solution, while from the anode you will come to know that from this cathode I can say that H plus hydrogen gas will liberate, and from here the oxygen gas will liberate. So electrolysis of aqueous NaCl, what is the result? We are getting two gases, that is a hydrogen gas and chlorine gas, and plus after the liberation of gases, we are getting a NaOH solution left inside the container. That means when electrolysis of NaCl is carried out, I can say that during that process NaOH is formed. And electrolysis of molten NaCl, this method is also known as a Downs process, DOWNS. So Downs process for the preparation of the sodium metal. This is nothing but the extraction of this, explain us the extraction of sodium from sodium chloride. Now this comes under the first category, that is the electrolysis. Why? Because see, I can say that till the electricity was not, suppose if I am not supplying electricity, then ions will not migrate, and if ions are not migrating on the opposite electrode, on supplying if I am not supplying electricity, then these electrodes will have no charge, so ions will not migrate. Ions will not migrate, that means they will neither lose electron or nor gain electron, means neither oxidation nor reduction will take place. And if oxidation reduction will nothing will happens, then ultimately the reaction will not take place. So all the things are starting only after supplying electricity, that is after switching on this battery. Then only these electrodes are getting charged, getting some positive and negative charge, and due to which the ions are migrating, they are gaining and losing an electron, and then so that reaction is taking place. So this is the first part, that is electrolysis of the electrolysis process.